we're going to do today is we're going to work on our second lesson on the exponents and power laws. We're going to get you to understand and apply the exponent laws for three more laws. These are the power of products, the power of quotient, and the power of powers. Now, in our last lesson, we covered the first two laws, and this they were taken care of. The one law we're not going to be working with is the negative exponent law. That will happen later. So let's get started then. The first one we're going to learn is called the power of a power. Now, what I want you to do is I want you to expand this out. Now, when you expand this out, this means you have the base, which is got a -3, and you've got multiplied by itself 4 times. That's what the 4 there means right there. So the exponent tells you how many times to multiply the base by itself. So we have -3 times -3 times -3. Now, the base here is -3. That means that you have to make sure you keep the brackets around the -3 to maintain that base being a -3. So it says here to multiply the base by itself 4 times, and that's from the exponent. And how do you know how many times to multiply it by? Well, that's what the exponent tells you. Okay, so let's see if we can get through this whole thing now. First off, let's consider the following. I've got 3 to the power of 2 times itself 4 times. That's what the 4 means. Take what's in the brackets and treat that like a base and multiply it by itself 4 times. So if the base is 3 to the 2 and I multiply it by itself 4 times, I have to take and put the 3 to the 2 inside a separate set of brackets, and I have to multiply it by itself 4 times. Now keep it inside the brackets because the 3 to the 2 is in brackets here. Now, once I know that, I can take 3 to the power of 2 and I can expand that out. Well, 3 to the power of 2 is simply 3 times 3. So that's what each one of these 4 becomes. Now, let's put them back into the power form. We learned last lesson that brackets don't matter when you're multiplying things by the same base. So this just simply becomes 3 times 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 3. There's 8 of them. So you put the base down as 3, you're multiplying by itself 8 times, and that means that the power is going to be 8. So 3 to the power of 2 to the power of 4 is 3 to the power of 8. Let's take a look at another example. This is 2 to the power of 3 raised to the power of 2. So let's expand this power out. You have 2 to the 3, and you're going to multiply it by itself 2 times. That means you have 2 to the 3 times 2 to the 3. Expanding that out, 2 to the 3 is 2 times 2 times 2, and 2 to the, this one here is 2 times 2 times 2 also. So when I take the brackets out, I can move and get 2 to the 6 because there's 1, 2, 3, 4, 5, 6 2's. That's your base. Multiplying it by itself by 6 times means it's 2 to the power of 6. Okay, so in your own words, you should be saying, when you calculate the power of a power, you multiply the exponents. Okay, so here's an example for you. 3 to the power of 2 to the 4, that's what we did. We found out that 3 is just simply multiplied by 2 to the 4. Now, if you go back to our example here, let's take a look and we'll show you how that works, okay? Here's 3 to the power of 4. We took this, and there's 3 to the 4, sorry, 3 to the 2 to the power of 4. You notice at the end, we had 3 to the 8. Now, 2 times 4 is 8. So this is your way to shortcut it without having to draw all of this out, okay? So this is like our distribution law. When you cross a bracket, you multiply, all right? So just take a look here. Here's our example. Here's another one over here. 2 to the 3 multiplied by itself 2 times. If you simply multiply the 2 and the 3, you get 2 to the 6, and that's what we got up here. So this is the way you do it. Whatever the power is on the inside, you multiply it by the power on the outside. So this is a to the m times n, and that'll allow you not to have to do all this expansion stuff. It's a shortcut, and it's accepted. So I want you to pause the recording, and I want you to take and I want you to do the following questions, okay? All right, so 3 to the 5, sorry, 35 to the 5, all to the power of 6 means we're going to be multiplying the 5 times the 6. Now 5 times 6 is 30, which means that we have 35 to the 5. This is your work. This is your answer. You always put the question down in your assignments. What about this one here? A little bit trickier. We have a -7 as our base, and it's raised to the power of 7, and there's our 8. So 7 times 8 is 56, so keeping the brackets around your -7, because that's the -7 is the base there, you just multiply the 7 and the 8, and that will give you 56. 4 to the 5 to the power of 3 means 5 times 3. That gives you 4 to the 15. And here, 3 to the 12 to the 12. Well, since 12 times 12 is 144, that's what you get there. 3 to the 12 times 12 gives you 3 to the 144. Hopefully, you got them correct. All right, let's move on to our next one. This is called the power of a product. Now, power of product means that you're going to have a product on the inside. Now, product is the result of multiplication. So we're going to be doing some multiplying on the inside, and they may be the same, they may not be. But we're going to be taking and applying a power to the outside of the product, which is in here. Now, if you take a look at this one, we'll expand it out. This is 3 times 6. I can take and multiply it by itself 3 times. So here's my 3 times 6, 3 times 6, and 3 times 6. Now, let's remove the brackets and rearrange the numbers and put them in place. So what I've done here is there's your 3, 6, 3, 6, 3, 6. I've taken the brackets out. When I put them all together, I have 3 times 3 times 3 and 6 times 6 times 6. So when we do that, 3 to the power of 3, and this is 6 to the power of 3. Notice that this here exponent on the 3 is a 1, and this is the exponent of 1 on this 6. So 1 times 3 gives you 3, and the 1 on the 6 times the 3 gives you 3. So it may seem that we're simply just placing this exponent here, 3, on top of whatever's inside, but that's not true. What we're actually doing is multiplying the powers. Let's take a look at one where we actually show you how to do that. This is 7 times 8, and we're raising everything to the power of 4. So this is going to be 7 to the 1 and 8 to the 1 on the inside. On the outside, we have a 4. So I'm going to multiply the 4 times the 1, just like we do in our distribution law, and the 4 times the 1 here. So that gives me 7 to the 1 times 4 and 8 to the 1 times 4. Now just carry out your multiplication. This is 7 to the 4 and 8 to the 4. Let's look at another example. Okay, I've got 5 to the 6, 5 times 6 to the all to the power of 4. Now remember, this is 5 to the 1 and 6 to the 1. So we're going to be multiplying the exponent on the 5 times the 4 and the exponent on the 6 times the 4. So this is what it should look like when you start out. 5 has a power of 1, 6 has a power of 1. And we're going to take and multiply this by a power of 4. So taking the exponent on the outside and multiplying it by the 1 here and the 1 here gives us 5 to the 1 times 4. And this is 6 to the 1 times 4. So that gives us 5 to the 4 times 6 to the 4. So in our own words, when you write down how to do this, the exponent of each power inside the brackets is multiplied by the exponent on the outside of the brackets. So the power here of each one of these on the inside, the 5 and the 6, they both have a power of 1, is multiplied by the power on the outside, which is the 4. And you can see that's what we did here. We took 1 times 4 and 1 times 4 here. So there's our 2. And of course, that gives us 5 to the 4 times 6 to the 4. All right. I want you to try the following. So pause your recording and see how it works. Okay. So remember, this is 3 to the 1 times 2 to the 1. So when we do this, 3 to the 1 times 2 to the 1, all to the power of 4 means that the 1 times the 4 is going to take place, and the 1 times the 4 is going to take place here. That gives us 3 to the 4, and 2 to the 4 here. On our second one, 12 to the 1 times 3 to the 1, all times the power of 5. So 12 to the 1 times 5, 3 to the 1 times 5 gives us 12 to the 5 times 3 to the 5. And the last one, next one, 6 to the 1 times 11 to the 1, all raised to the power of 6, means that we have 6 to the power of 1 times 6 and 11 to the power of 1 times 6. And that gives us 1 times 6 being 6 is 6 to the 6 times 11 to the 6. And the last one. This one's a little bit trickier because I have a negative here, so you've got to keep your brackets around your negative. So I've got negative 3 to the power of 1 times 5 to the power of 1 multiplied by, raised to the power of 8. So again, this one here is going to be multiplied by the 8, and this one here is going to be multiplied by the 8. That gives us negative 3 to the 1 times 8, 1 times 8 being 8, gives us negative 3 to the 8. You notice I kept the brackets around the negative 3 all the time because that forces the negative to stay with the 3 and be a negative base. All right, and then 5 to the 1 times 8 gives us 5 to the 8. All right, the third one. It's called power of quotients. Now, power of products meant that inside the brackets we were multiplying. Power of quotients means that inside the brackets we're going to be dividing. Quotient is the result of a division question. So if I have 4 over 7, all raised to the 3, first let's just do this the old way. 4 to the 7, right, raised to the power of 3 means multiply 4 to the 7 by itself 3 times. Now, if you remember how to multiply fractions, you multiply the numerator by the numerator and the denominators by the denominators. So this turns into 4 times 4 times 4 over 7 times 7 times 7. So now, let's convert the numerator and the denominator back into powers. So there's 4 here, and 4 here, being 3. That means the base is 4 multiplied by itself 3 times. That gives us 4 to the 3. Here the base is 7. You're multiplying it by itself 3 times, so that gives you 7 to the 3. So when you look at this, you'll see 4 to the 3 gave you 4 to the 3, and 7 raised to the power of 3 gave you 7 to the 3. Now remember, the power here is a 1 on this 4, and the power here on the 7 is also a 1. So we're not just taking the 3 and putting it on the 4, and the 3 and putting it on the 7. What we're actually going to be doing is multiplying just like we did in our previous lesson. So 4 over 5 raised to the 4. So do it the expansion way. 4 over 5 multiplied by itself 4 times. And that gives you 4 to the 4 over 5 to the 4. Now, drawing all this out is going to be repetitive, especially when the numbers get bigger. So we have 4 over 4 to the power of 1 over 5 to the power of 1, and we want to raise all of this to the power of 4. All we have to do is multiply each one of these exponents by the 4 that's on the outside, just like we did before. When you cross a bracket, you multiply. So 1 times 4 is 4, 1 times 4 is 4, resulting in 4 to the 4 over 5 to the 4. So how do we do this? Each power on the inside of the bracket, both numerator and denominator, have their exponent multiplied by the power on the outside of the brackets. Note that the whole numbers have an exponent of 1. Alright, so here's 4 examples. You try these. Alright, so this is going to be 5 to the 1, 11 to the 1, all raised to the 4. So it's going to be 5 to the 1 times 4, and 11 to the 1 times 4. That gives us 5 to the 4 over 11 to the 4. Again, this one here. There you go. Negative 4 is kept inside brackets to force the negative to stay with the 4. That gives me a negative base in all 3 cases. 5 is the exponent on the outside. 1 is the exponent on the inside. So it's 1 times 5 giving you a 5, and 1 times 5 giving you a 5 here. Same thing here. 6 over 17 is 6 to the 1, 17 to the 1. Multiply them both by 7 gives you 6 to the 7 over 17 to the 7. Same thing happens here. 1 has a power of 1, 5 has a power of 1. 1 times 8 gives you 1 to the 8. 1 times 8 here gives you 5 to the 8. Now you may be asking yourself, why don't I just put powers on the inside? We will be doing this later, okay, when things get more complicated. I just want you to get the simple stuff first. All right. So now that we've got the 3 laws covered, and there's the other cause that we've already done, let's take a look at seeing how we can do with the BEDMAS questions. Now, BEDMAS is order of operation. If you remember, BEDMAS, B stands for brackets, so when you have B, a bracket, you have to do everything inside the bracket first. Then you do the exponent on the outside. We won't be doing adding and subtracting much here at this part, but we will be doing some multiplying and dividing of bases possibly. So let's take a look. 4 to the 3 times 4 to the 5, all raised to the power of 2. Our first goal is to get rid of, or sort of solve, the inside multiplication. 4 to the 3 times 4 to the 5. Now, when the bases are the same, we simply add the exponents. So there's your 3 plus 5. So that leaves us with 3 plus 5 being 8, 4 to the 8, all raised to the power of 2. Now, when you cross brackets, you multiply by 2. So 8 times 2 gives you 4 to the 16. All right. Okay, let's take a look at question B. In question B, we have 2 to the 3 times 2 to the 5, all over 2 to the 4, and this whole division is being raised to the power of 5. So we have brackets here, so that means I have to deal with the 2 to the 3 over 2 to the 3 times 2 to the 5 first inside here. So I'm going to deal with the top numerator first, and then I'll worry about dividing in a second. So here's our question. My first job is 2 to the 3 times 2 to the 5. When you multiply powers that have the same base, we simply add the exponents. So 3 plus 5 giving us 2 to the 8. Now that we're still inside brackets, so 2 to the 8 divided by 2 to the 4. When you divide fractions with the same base, we subtract their bases. 8 minus 4 giving us 2 to the 4. Now that I've got the inside of the brackets all taken care of, now I can deal with the power of 5 that's on the outside. Remember, when you cross brackets, you multiply. So this is 4 times 5. So this gives me 2 to the power of 4 times 5, which is 2 to the power of 20. Okay, let's take a look at question C. You'll notice in question C that there are two sets of calculations here. There's 4 to the power of 3 to the power of 7, and 4 to the power of 3 times 4 to the power of 7, all multiplied by the power of 2, or raised to the power of 2 here. You'll notice there's square brackets here. Now, because BEDMAS starts with brackets, these are the things we have to deal with first. So inside this set of square brackets, we have a set of rounded brackets called parentheses. So I have to deal with 4 to the 3 times 4 to the 7 first. Now, when you multiply things that have the same base, we simply add the exponents. So 4 to the 3 plus 7 gives us 4 to the 10. Now I still am inside the brackets, so I've got to continue here. 4 to the 10, all raised to the power of 2, gives me 4 to the 10 times 2. Now that means that I've got to multiply 10 times 2, which gives me 4 to the 20. Now at this point you can drop the brackets or you can keep them. Let's go back and take a look at the first one now. 4 to the 3, we're crossing the bracket, so if this becomes 3 times 7. 3 times 7 being 21 means we now have 4 to the 21 times 4 to the 20. We can take the brackets out, make it look a little cleaner. Again, the bases are the same, so we can just add the exponents. That gives us a final answer of 4 to the 41. All right, take a second and try D and see how you do. Okay, let's take a look at this. Again, we have two sets of brackets here. So when you have two sets of brackets we have to work with, we do them in the order that they appear. So we're going to worry about 3 to the 3 times 3 to the 7, all raised to the power of 6 first. Inside here, when you multiply powers that have the same base, we simply add the fractions. Add the exponents. So this becomes 3 plus 7. Well, 3 plus 7 is 10. We're still inside the brackets, so now we have to deal with 10 and the 6. When you cross the brackets, you multiply. So this becomes 3 to the power of 10 times 6, which gives us 3 to the power of 60. Now let's go take a look at the other one. Same thing happens here. I'm inside square brackets, and then I'm inside the rounded brackets, so the 3 to the 4 times 3 to the 2 has to come first. The bases are the same. We're multiplying, so we add the exponents. 4 plus 2 give me a 6. Now we can deal with the 6 and the 5. Crossing the brackets means we multiply, so 6 times 5 is going to give me 30. Now, we take a look at 3 to the 60 times 3 to the 30. The bases are the same, so we simply add the exponents, 60 plus 30, and that gives me 3 to the 90. All right, have you try this one here? Pause the recording and give it a try. All right, so we've got two sets of brackets again. 3 to the power of 3 divided by 3 to the power of 2. Now when you divide powers that have the same base, we subtract the exponents. So this becomes 3 take away 2, which gives us 3 to the 1. All right, now we'll deal with 1 to the 4. 1 times 4, because we're crossing brackets, gives me 3 to the 4. All right, let's take a look at this one over here. 3 to the 5 divided by 3 to the 2 means we now have to take and subtract the exponents, so this becomes 5 take away 2. 5 take away 2 is 3, so now we can take and deal with the 3 times the 5. 3 times 5 is 15. So we have now got 3 to the 4 times 3 to the 15. The exponents are, the bases are the same, so you can add the 4 and the 15. And that gives you 3 to the 19. Now, this is a review sheet that's in your notes, and what it does is it tells you all the power of product stuff you need to know. So start with the first one, product of powers. Now what this means is you're going to take things that have the same base and different exponents. Now when you multiply things with the same base, an a, and you have different exponents, an m and an n, you simply add the two of them. So here's an example. 4 to the 4 times 4 to the 2 gives you 4 to the 4 plus 2, which is 4 to the 6. This is your review for your quotient of powers. You have a to the m divided by a to the n equals a to the m minus n. So when you have a division occurring between two powers that have the same base, we subtract their exponents. Now there is a little bit of a rule here. The m cannot be greater than the n here because in our rules we're not dealing with negative exponents. Now you will get to that, and this won't matter in 10-C. So what happens? You have a to the m over a to the n. This is another way of writing a division question, and that is a to the m minus n. Here's an example. 5 to the 6, the bases are the same, so we subtract the exponents, giving us 5 to 2. Okay, power of powers. This is a to the m, all raised to the power of n. When you cross the brackets, it's like the distribution law. We multiply, so this becomes m times n. Here's an example. 3 to the 4, all raised to the power of 5, is 3 to the 4 times 5, and 4 times 5 is 20. Okay, power of products. This is where we have a product on the inside, and we raise the power on the outside. So a to the 1 times b to the 1, all raised to the n. Now again, this one here was a little bit of a mistake on my behalf. This is actually a to the 1 times 5. So I put it in the example here. Don't forget that the a is a 1 and the b is, so a has an exponent of 1, and so does the b. So this is actually n times 1 and n times 1, which results in n. You can also write this as a to the n, b to the n, taking out your multiplication if you're working with variables. So in our example, this 3 becomes 3 to the 1, 2 becomes 2 to the 1. We're crossing the brackets, so 5 times 1 and 5 times 1 here gives you 3 to the 5 times 2 to the 5. Okay, power of quotient. Same thing happened here. A over b, these are both powers of 1. You multiply the n times the 1 to get n, and the n times the 1 down here to get n. The only thing here is b can't be 0 because then that would give you an undefined number. You cannot divide by 0. So here's the example. 2 to the 1 times 4 is 2 to the 4. 3 to the 1 times 4 is 3 to the 4. Okay, so it's time to go on to your last assignment and then practice up so that you can do your final exam. See you later.